Hi guys, I gave you a video on diffusion, facilitated diffusion, and active transport. Here's your one on just osmosis. It's also a type of passive transport. So just like diffusion, just like facilitated diffusion, osmosis is not going to require energy, and it's also going to move from high to low concentration. And again, that's just like diffusion did, and just like facilitated diffusion is. Only difference here, guys, is when we talk about high to low, we're talking about more the concentration of solute to solvent. So I'm just going to kind of jump into some examples here real quick. We got 3 of them, okay? So I'm going to start just on that side, and what we're going to be concerned about with assigning our vocabulary words is going to be our amount of solute present, either inside the cell in this area or outside of the cell, which would be in the solution. I did a little water line here, and in the water and also in the cell, there's going to be a certain amount of solute. So I'm just going to draw some solute particles in there, and I'm going to draw a few outside in the solution as well. All right. So if we count them up, obviously in the solution, I only have 4 solute particles. Inside the cell, I have much more. So what we want to do first is determine, okay, what is hypertonic and what is hypotonic? We already talked about in class that hyper means above and hypo means below. This is referring to the solute particles. So if it's hypertonic, that means that area has more solute particles compared to the other one. So in this one, we have our cell, and our cell has more solute particles. So for this one, we would say that the cell is hypertonic. Okay? In other words, the cell has more solute particles. But we can also say that the solution, since it has less solute particles, is hypotonic. Okay? So we assigned our vocabulary words. We know that it's a hypertonic cell because it has more solute particles, and the solution is hypotonic, meaning it has less solute particles. Our next thing to determine is, where is water going to go? Water is always going to go to where there are more solute particles. So in this example, we're going to have water inside the cell because cytoplasm is pretty much mostly water. And then outside, in the solution, we're also going to have water. So water could move into the cell, water could move out of the cell. We just got to determine which way is it going to move more. So since there's more solute inside of the cell, that's where it's going to move to. Okay, so our water is going to be moving into the cell. Okay, now in turn, since the water is moving into the cell, okay, we're going to get more water inside the cell, a larger volume of water. So in this example, the cell is going to grow. Okay, so that's with hypertonic cells or hypotonic solutions. The cell will grow in the end. Okay, so that's that one. Let's do the reverse of that. So let's say for this one, instead, we're going to have a whole lot of solute outside of the cell, and maybe just a little bit in. So assigning our vocabulary words, we're going to have hypertonic and hypotonic, but we got to determine, okay, is the solution hypertonic or hypotonic, and is the cell hypertonic or hypotonic? So in this one, I obviously have more solute outside of the cell. In other words, it's in the solution. So this one would be a hypertonic solution in a hypotonic cell. All right. Last thing we're going to do is determine, where is water going to move? Well, water is always going to move where there is more solute. So for this example, water is going to be moving outside of the cell. In turn, since water is moving outside of the cell will shrivel or gets smaller, okay? A little bit different, exact opposite of what we did in the first example. In the first example, water was going into the cell was growing, getting bigger and bigger and bigger, and that could lead to cytolysis, which is the cell getting so big that it literally bursts like a balloon. In this example, exact opposite with our hypertonic solution or hypotonic cell, the cell shrivels, all right? Last example, probably the easiest one. We already did one where there's more solute inside the cell. We did one where there's less solute inside the cell. This one, what if we have an even amount, or we could say an even concentration of solute to solvent inside of the cell and outside of the cell? All right, I'm just going to do it easy here and make it so that we have the same amount of solute on each side. And overall, we're not going to have water completely stop moving. There's still going to be water going into and out of the cell, but the only difference here is, compared to the last one, we're going to have water going in, and whatever that amount of water is going into the cell, we're going to have that same amount of water coming out of the cell, okay? So overall, this is called an isotonic solution, or we could just say it's isotonic. Water still moves inside into the cell and out of the cell, but the cell stays the same size. Okay. So overall, there is movement of water, but there's no net movement, no gain or loss of water into or out of the cell. All right. So this is your 3 types of osmosis, guys. You know, just make sure you're able to assign, okay, what part, either the solution or the cell is hypertonic, which part is hypotonic, and where's water going to move. If you guys got that, you'll be fine. All right, guys, hopefully this helped along with the other video on diffusion, facilitated diffusion, and active transport. Have a good one, guys.